Hello, algebra students. Mr. Lawrence here, and some of you are working so hard on some of these vertical motion problems that I wanted to go over two of them for you really quick, and I'll even include some graphs and things like that. So let's get started. A ball is kicked off a platform that is 8 feet above the ground with an initial velocity of 45 feet per second. We're going to assume it's being kicked upward. Okay, A, how many seconds will it take to hit the ground? B, how high will it go? C, how many seconds will it take to reach the max height? And D, after how many seconds will the ball be 30 feet above the ground? Oh my gosh, it's too much information, I can't do it. Well, stop, don't do it. The problem is you're psyching yourselves out. Let's draw a picture. So let's see here, I think I need a platform, right? So let me get a platform in here. Hold on, let me get my calligraphy pen. I like that so much better. Okay, so here's my platform. All right, and here's my kicker. They're looking a little malnourished here. Okay, and here's the ball. And it's going to go up and then come back down, right? Okay, now, what's it hitting? Well, it's hitting the ground, right? So the platform must be centered on the ground. Yikes. Okay, that'll work. I'm just going to extend that ground a little bit there. I don't want it going into a hole. That would be a different question. There we go. Hit that pretty good. Okay, now there's my picture, and let's see what question A says. How many should be seconds. Silly Mr. Lawrence. Gonna let me fix that? It is. How many seconds will it take to hit the ground? Okay, well, what am I talking about? I am talking about this place right here. Now, if the ground is like the x-axis, this is the place, like Gabby Mormon would say, where the parabola hits the x-axis. So I want the quadratic formula. Remember, the quadratic formula finds me solutions, and the solutions or the roots are the places where the parabola hits the x-axis. So I'm going to need x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, very good. Now, I can't use that until I create an equation. So, my equation is of the form h equals negative 16 t squared plus or minus b sub o t plus s. And I remember what all those things stand for. If I don't remember, I'm going to look them up because we wrote them in our notebooks. Okay, so let me see if I can get the equation developed here. How many seconds will it take to hit the ground? Let's see, initial platform 8 feet above the ground, initial velocity 45 feet per second. So my initial equation is going to be h equals negative 16 t squared plus 45t. And Justin Stahorsky can tell you that it's plus 45 because the ball is being kicked upward. If it was being kicked downward, it would be minus. Okay, 45t. And the starting height is 8 feet because it's 8 feet off the ground. It's up on that platform. Now I can go to the quadratic formula. Okay, I could try solving by factoring or completing the square. It'll be so much easier with the quadratic formula. A little bit long, but easy. So, first thing I'm going to do is talk about Michael Jackson. Go A, B, C. Easy as negative 16, 45, 8. And I'm going to plug it in. So I'm going to go x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to simplify this quite a bit. I'm not going to go and like do it all in one shot, but I'm going to simplify it. And so I'm going to figure out my discriminant, and that'll make my problem a whole lot easier. So I'm going to have negative 45 plus or minus square root. It's going to be over negative 32 And now I'm going to go to my graphing calculator, and I've got to do my discriminant. So let me get my graphing calculator up, and let me get out of that. And so I'm going to have 45 squared minus 4 times a quantity of negative 16 times 8. And there we go, 2537, 2,537. So that is my discriminant. That is the value underneath the square root. What did I say, 37? I think so, 2537. Let me just double check that, because if I've got that wrong. Okay, good. So now I'm going to go negative 45 plus the square root of 2537. And it gets me that, and then I have to divide it by negative 32. And I'm going to get this really large negative, very close to 0. But I don't want a negative time. That's where it would be on the ground if I went backwards in time from the platform, which doesn't really make sense. So now I'm going to have to do negative 45 minus the square root of 2537. And I'm using my second enter to make my life a little bit easier. Oops, I went a little bit too far. So I'll change that to a minus. I'll get the answer. I'll divide by negative 32. And it's going to hit at about 2.98 seconds, pretty darn close to 3. So I found that x is going to equal, I got a negative answer, but I'm throwing it away as an extraneous root, 2 98/100 seconds. Now, that's not the exact answer. That, of course, is rounded. But if I go to my graph here, check out this graph, okay, and you see here I have the parabola being graphed. Let me change that x window. We don't need to see 10. Let's go to 5. Okay, that looks a little bit better. And I hit trace. Hey, look, at 2.5 seconds, the ball is 20.5 feet off the ground. That's what that's telling me. X is like t, 2.5 seconds. H and y are the same. That's the height off the ground. Now, what do we get? 2 98/100? Now, remember, that's a rounded answer, but watch what's going to happen when I plug in 2 98/100 into x. Look at that. I get a number pretty darn close to 0. It's going to be a little bit off of that. What was that long decimal? Let me see if I can do it more accurately. 0270032. 0270032. So let me go 2.980270032, I think is what we said. Now watch how close to 0 this is going to be. Look at that. That's times 10 to the negative 8. That's pretty close. What it means is we had an irrational number in our answer, and so we're rounding it, so we're not getting 0 on the nose. But we know we're very, very close. Okay, so that's part A. A is going to be 2 98/100 seconds. So let me write that down. So 2 98/100 seconds. And that's close enough for what we're doing here. Okay. Now, B and C are easy but tricky. They actually should be written backwards, meaning C should be in B's place and B should be in C's place. And you'll see why in a minute. How high will the ball go? Well, that means I'm looking for this point up here, right? Which should be the vertex. And to remember to find the vertex, I'm going to use t equals negative b over 2a. And then that will get me the time it takes to get to that height. And then I'm going to take that number and plug it in for t into my equation, and that'll get me the max height. So let me do that. So I'm going to recopy my equation. Normally you'd have it in front of you, but you can't see it. So it's going to be h equals negative 16 t squared plus 45 t plus 8. Okay, so t equals negative b over negative 32. 2a, right? Okay, I know the negatives will cancel. And that decimal, I don't know off the top of my head, is going to be, let me quit out of that, and go 45 divided by 32. And I get this decimal. If you want to round that to 1 4/10, that's fine, or 1 41/100, that's fine. I just answered C. That's how many seconds it will take to get to the max height. Let me see, 1.40. Here, let me try this. Let's go to graph. And I'm going to hit trace. And what did I do? I did 45 divided by 32, right? Look at that. Where's that sitting? It's sitting at the vertex. And look at that x-coordinate, or that t-coordinate, 1.40625. That's what I got before. Now I know the max height, but we're gonna go and figure it out and make sure we get it right. So if I know that that's the max, that's the time it takes to get to the max height. Watch what I can do. I'm going to go negative 16 parenthesis. Now instead of typing 1.40625, that's the last answer on the screen, right? Down here is an A and S button. Most of your calculators have it right above the negative. I'm going to hit second, enter, and that A and S means 1.40625. Okay? I'm going to square it. Then I'm going to add 45, and I have to multiply by the 1.40625. Well, I'm just going to second negative it again, and the answer shows up. And then I have to add 8. And there we go. I get 39.640625, right? So trace, graph, trace. Look at that, 39.63196. Okay, almost the same exact thing. Okay, it's a little bit off here. A little bit off. I'm not sure why. But anyway, that is the max height for the vertex. So 39 6/10 is fine. And, oh, I know why it's off, because I didn't put the right thing in. I have to do 45 divided by 32. And there we go. Now it matches perfect. Good. Okay, so I've answered B and C, although I did them backwards, right? I ended up doing them backwards. So how high will it go? It will go approximately 39 6/10 feet. How long will it take to get to the max height? About 1 4/10 seconds. Okay. Now D is actually a super duper easy problem. How many seconds will it take the ball to get 30 feet above the ground? Well, this is very much like hitting the ground when H is 0, right? But in this case, H is going to be 30. So H equals negative 16 t squared plus 45t plus 8. And this time, what did I say, 30 feet? Yeah, it's 30 feet. So I'm going to put 30 in here, and I'm going to use the quadratic formula. Now, careful, I can't find A, B, and C yet. I'll bet you Iris can tell me why. That's right, Iris, it doesn't equal 0. So I'm going to subtract 30 off, and I'm going to get 0 equals negative 16 t squared plus 45t minus 22. All right, so now I'm ready for the quadratic formula. And so I list A, B, C. Easy as negative 16, 45, negative 22. And I'm going to go T equals negative 45, the negative of B, plus or minus the square root of 45 squared minus 4 is negative 16 times negative 22. The whole thing is over negative 32. 2 times 8, right? All right, so I'm going to simplify it. Negative 45 plus or minus square root of. I'm going to go find the discriminant, and I'll write it in there, over negative 32. So what do I have? 45 squared, 4, 16, and 22 all negative. Okay, so my discriminant is going to be 45 squared minus 4 times negative 16 times negative 22. And there's my discriminant, 617. Okay, so I'm going to put 617 right here, and then I'm going to go to my calculator. So I'm going to go negative 45 plus the square root of 617. And I'm going to divide that by negative 32. And so it'll be at 30 feet in about 0.63 seconds, so about 63 hundredths of a second. Okay? Or if you're going tenths, you can do 6/10 of a second. All right, then I'm going to second enter. I'm going to do second enter again because I want to do negative 45 minus the square root of 617. Trying to work more efficiently here because these problems take a little bit of time. Okay, and I get that, and I divide by negative 32. And I get about 2 1/1800 seconds. So I've got 63 hundredths and 2 1/18 hundredths, and that's the answer to B. To D, excuse me. So at 63 seconds, and again at 2 1/18 hundredths seconds. Okay, now if I go to that graphing calculator, and I hit the graph, and I hit trace, and we set it about 0.63. Now that's rounded. Look at that. I'm pretty darn close to 30, aren't I? If I went a few more decimals, I'd be like right on 30 exactly. 0016. Let's see if that'll do it. Let's go 0.630016. Oh, you can't get much closer, but it's pretty darn close to 30. Okay, and the other one was what, 2 1/18 hundredths? And that's going to be at 30 feet on the way down. And notice that's just a hair above. And again, if I go to the closer decimal, 182483. 182483. 182483. And look at that, pretty darn close to 30. Okay, my t was a rounded number, or my x was a rounded number, so that changed things a little bit. Okay, so there's that one. Now, let's see here. Here's another problem. As a going away present for Miss Halter, several students rent a hot air balloon so they can drop a water balloon on her as she walks to her car. If the hot air balloon is 90 feet above her, I guess I left the word out of there. All right, above. I said her, and I should have put the instead of her. Above her, when they drop the water balloon and it misses Miss Halter, exploding on the ground, determine how long did it take for the balloon to fall to the ground. All right, so I'm going to draw my picture. So let's see here. And I'm not going to worry, you know, Mrs. Winmouth isn't grading me on this. I'm just doing a little cheesy picture. So I got my hot air balloon here, right, going up like this. Okay. And then I've got somebody in here thinking they're funny, and they're dropping a hot air balloon, right? Oh, excuse me, they're dropping the water balloon, not the hot air balloon. And it's going to go down vertically like that. Okay? Now, down here on the ground, and here's Miss Halter. Unsuspecting, going about her day all happy, and the balloon explodes next to her and does not hit her. Okay? So, we know that this distance here is 90 feet because the story told us so. Okay. We want to use that equation that we've been using so much of. So h equals negative 16 t squared plus or minus v sub o t plus s. Okay, so now let's fill in what we can. Well, we know the ending height is going to be 0. Why? Because it's exploding on the ground. Negative 16, we don't know t, that's what we're solving for. We'll use something here in a second. Okay, whoop, the initial velocity is going to be, what's that? Yes, 0, because it's being dropped, so I'm not even going to put in the plus or minus v sub o t, and s is 90. Now you have a couple choices here. A lot of you want to solve this using inverse operations, and that's a pretty good idea. I don't think I'd try to factor this one. You could, but I don't think I'd recommend it. You could try completing the square, but again, I don't think I would recommend it. Okay, so I'm going to go quadratic formula because I know it's going to work. That's going to be my fallback. So I'm going to identify A, B, C. Easy as negative 16, 0, 90. Okay, so t is going to equal 0 plus or minus the square root of 0 minus 4, negative 16 times 90, all over negative 32. Okay, so I'm going to figure out my discriminant. I'm going to have 0 plus or minus. I'll have to figure that out. Or negative 32. So let me see here. Let me go to my calculator and do my discriminant. And I'm going to get negative 4 times negative 16 times 90. And so my discriminant is going to be 5,760. So let me get that in my formula. And so now I'm going to do positive 5,760 divided by negative 32. But that's going to give me a negative time, isn't it? So you know what? I'm not even going to do that one. I know that's not going to be relevant to this problem. So I'm going to do the negative of square root. Hey, by the way, I can do that answer thing right here because the last number up there was 5,760. And I'm going to divide that by negative 32. When I do that, I'm going to get about 2 3/37 seconds. And there you go. That's how long it took to hit the ground. Okay? All right, so hopefully you're working hard on this. Mr. Lawrence signing off. Have a good night, everybody.